Hello everyone, we're doing 2023 IIT JEE Advanced Paper 1. We're on section 4 and we're down to the last problem, which is question 17. And this question is a standard question. You see it in textbooks. It's a textbook problem, but on the interesting side, okay? And you have to do it. You can do it really just formula manipulation and you'll be okay, but I'm going to do it a little bit differently. All right, so in this question you have a situation is given, and in that situation you have a list of possibilities here. These are things you need to calculate, and these are the answers, list of answers that are possible. Okay, and so each question has matching answer, and these are all definitely the answers to some question, right? And then the best one that matches all of it is the correct answer. And you make the correct answer, you get a +3. You get a wrong answer, you get a -1, and they're all balanced. Okay, so my strategy is to see when you read the question and see which one of the things I need to calculate and which one I can really calculate. So if you know how to calculate any one of these, you just go ahead and calculate that first. If you know a whole bunch of them to calculate, then you figure out between these choices which one distinguishes the most. So let's look at what P goes to 5, 4, 3, 3. So if I actually land on 5 or 4, it is distinguishing in a way. So the induced EMF at a particular time is distinguishing. So one of these answers, then if is 5 or 4, then actually I'm done. Instead of land at 3, I need to do some other problem, maybe do Q then. But S will not distinguish. So if you do S, you can also the same kind of situation. All right. Okay, so in terms of doing, say, P or Q or R, I need to know induced EMF as a function of time. This is magnetic force on this moving bar as a function of time, power dissipated as a function of time. So we need to figure out this something as a function of time, right? So what is the situation here? There is a bar that's moving on this this rail, which is seems like a vertical rail because the gravity is down this way. So you can think of this as the bar is like hanging. Let me show you by my hand. The bar is hanging vertically, and things will fall down rather than on a table. So this motion is not on a table. Okay, and these are the direction of magnetic field. So kind of, if it's vertical, then the magnetic field is coming towards us. All right, so it's perpendicular magnetic field. Everything is really set up nicely. So what is not given is, if you look at it, the rod is released from rest at time t equal to 0. What's not given is or the rod over here at t equals 0 or over here, or it's not given. So I'm going to just assume the rod, that's going to be my assumption, rod here at t equal to 0 at speed 0. So I'm going to just say it was released at rest. It tells you release from rest, and then it moves, it starts to fall down, but it keeps in contact. While it's falling down, it's keeping contact with the rail. All right. You can immediately see that the area will be increasing. So physics wise, you can say that magnetic flux will be increasing through the area enclosed. And so there will be induced EMF whose flux will be actually opposite of this. So the current will be induced. So you can actually see that from this setup you can already see at set t, and then this is t plus delta t. So you got this much area more flux coming in of this variety. That means induced one have to be like this, induced one. So that has to be, current will be this way. And if outside magnetic field is that way, then this current will have a force, magnetic force will be pointed up, and the gravity will be pointed down. It's like this. So you know something like this is going to happen. But we need to be able to keep track of what the position of the rod is at any time t. So for that purpose, we're going to say that this is say x-axis, and say I'm going to put y-axis down, so that this is the y at t. Okay, and y of 0 is 0, and y dot of 0 is 0 dot d dt. It stands for time derivative. Okay, so this velocity is 0, and clearly if the current in this time instant is I of t, then magnetic force at that time t is going to be upward. The y component is going to be minus I, and this distance is L, IL B, and I is a function of time. So this is a different time, and what is I of t will be magnitude of the current is magnitude of the induced EMF over the resistance of this wire. Resistance here is 0, resistance here is 0, resistance is 0 is 0. This is the only part that's resistance, and in the whole circuit, this is the whole circuit, and this whole circuit there are only resistance of the circuit, and that just a resistance in the wire. And what is the E induced? E induced is going to be is going to be d phi dt. And what is d phi? Phi is what is the flux through this, the phi of the B field is going to be B times L times the Y. So that's the flux. So that just becomes, taking a time derivative of that just gives me BL over R dt, and y is dy dt is positive, is going this way. All right, so that's why I don't have the absolute value here. So all right, so E induced T equal to just BL dy dt. So these are the formulas we will need. Okay, noticing that in our B is 4 Tesla, B equals to 4 Tesla, and L equals to 0.25 meter. That makes it BL equals to 1. So if in this exam situation, you can just call this guy 1, call this guy just 1. So I will have to figure out this, and I'm done. So how do I figure out this? Let's call it, so that will be the equation of motion. So we got the rod. So equation of Newton's equation of motion. It's a pretty cool problem actually. So m y double dot, that's mass to y acceleration, equals to gravity is positive here because the y-axis is this way, because the y component of gravity is mg. This one is negative, minus il. So BL is 1, so minus I of t, and I of t is just dy dt. So this is equal to mg minus y dot. So bring divide by m everywhere, and y dot plus 1 over m y dot equal to g. The m equals to 20 gram, so equals to 0.02 kilogram. So 1 over m is 100 over 2 is 50 per kilogram. And I don't want to carry in units, because in the end all the units will have to work out, right? Because I already divided by BL and I just use them all. So let's call it V, denote V for y dot. Then this equation is simply V dot or dV dt plus 50V equals to 10. And we can solve this, right? And how do you solve it? Well, it's going to be V of t will simply be, this over this, right? So like a 10 over 50 times 1 minus so I see these numbers to be quite off. So the reason I know this off is going to be e to the power this number minus this number, which should be, it says 50t, but that actually can't be that, because the question here is 0.2. So put 0.2, 50 times 0.2 is actually 10, but what's given here is e to the minus 1. So I think there's something went wrong. Let me just check. At this point I go back, so IT is y dot, y dot over r. So that's what the mistake is, y dot over r. So y dot over r. So when I divide by m, I should get mr. So 1 over m is 50. So I should divide by 1 over mr is 50 over 10 is 5. So this is not 50, this is not 50, but this is actually 5, and so this is actually 5, and so this is actually 5. And then when I do this, I'm going to get 1, and this will become e to the minus 1 when I calculate the further. So this v of t is 2 times 1 minus e to the 5 t. Let's make sure that v of 0 is 0. Yeah, that's correct. And let's also make sure if I do v dot equals to minus plus 10 e to the minus 5t. Okay, so do I get v dot? If you look at over here, v over 2 equals 1 minus e to the minus 5t. So v over 2, 1 minus v over 2 is e to the minus 5t. So 10 e to the minus 5t is equal to 10 minus 5v. So multiply by 10. So this is equal to 10 minus 5v. Bring 5v up here. So v dot plus 5v equals to 10. And that's the equation. So everything is consistent. So I did some guessing here to write the answer like that. If you don't know how to do this, you may have to learn it somewhere else. Okay. So we got v of t is equal to that. So now we're ready to answer, right? So our distinguished thing I wanted to do over in terms of question was P. I now can do P for induced EMF. Even for Q, I can do P and Q very quickly. So, and so if I look at induced EMF, is same as V. So let's look V at 0.2. That will be E induced EMF. So this is 0.2 at 0.2 seconds. So I got a 2 times 1 minus e to the power minus 5 times 0.2, and that's just 1, and it's given at 1 minus 0.4. So 2 times 0.6 is 1.2. So let's look at where does it fall. So this 1.2, so P goes to 3. P goes to 3 is B or D. So answer is B or D. See, in the B or D, I can't use S to distinguish them, but you can do Q or R. So if you do Q, so let's do Q. So Q, magnitude of magnetic force. So magnetic force is minus I. So is magnitude of the magnetic force will be just LB is 1, so it's equal to the current at that time, and the current at that time is V over R, and V we already found is 1.2, R is 10, so this is 0.12. Let's see what 0.12 for Q. 0.12 is 4. Q goes to 4, so it's a D. So this just Q goes to 4, possibility that rules out B, and answer is D. Don't need to do more than that, but if you are really more curious about things, you can just work. This is the end of the question paper, and you can just keep going till you find all of this. Well, if you're curious about terminal velocity, V t goes to infinity, that's terminal velocity. So over here, t goes to infinity, this goes away, equals to 2. So that phi s goes to 5. That's correct answer. That doesn't distinguish between B and D, so is irrelevant here for the way we did it. And if you want to do power dissipated, so if you look at this circuit, this is the only place power is dissipated, right? This is only resistance, and there's no place else this EMF is going to drop. EMF is going to drop only here. So you can say power dissipated is equal to E induced times the current, and at that time, and you found E induced is 1.2 and the current we found 0.12, so 144, but instead, so this is going to be over here 1, 2, 3 decimal places, and round it up is going to be 0.14. So let's see, you have a 0.14. Yes, we have an answer 2, and that confirms our belief that it was D. So D is the answer. You really don't have to do so much confirmation. We already got this answer from earlier too, and that saves a lot of time. I think this test for 1 hour can be done about 40 minutes if you rush through it and don't do unnecessary calculations. Okay, that wraps up paper 1. Next I'm going to do paper 2. Just for a preview of paper 2, this was paper 1, and I think I have somewhere paper 2 printed out. Yeah, I've got a paper 2 here. So this paper 2 appears to me a little bit has some really trivial questions. Okay, so paper 2 has some good questions. This question, some of them are like really warm-up questions, and then you have situation problems which are also a little warm-up, not standard problems, not that complicated new problems. Okay, and some really silly problems here. Then some thinking problems now start. Okay, sometimes the questions have a good made up new problems. All right, now this one, this is thermodynamics, and this is kind of a standard problem. Then you have a interesting made up paragraph problems. I like this kind of problems now. This is detailed analysis of a situation. Each paragraph usually has 2 questions, and sometimes can be confusing because there's just a little bit different between the scenarios, but I think this is interesting addition to the problem. And then here is like another good problem, kind of combines thermodynamics and fluid flow and things like that. Okay, so I'm going to stop here. We are going to do this second paper section by section in another video. So I'll see you around. Bye.